today I get to teach you scale factor, or scale factor, yeah. Scale factor.
Is it still shapes?
Yes and no. Easier shapes. Okay. Is this a puma or a tiger? Can we tell?
It's a cat.
It's a puma?
Tiger's
Tiger has what?
It's a female lion.
Who said that?
So a tiger? No, female.
Female lion because
That's a mountain tiger. That's a mountain lion.
the name.
Right. Mountain lion. Mountain lion. That's another good one. Puma. Well, I don't know. So it's a big cat. All right. It's a big cat. All right. I don't know what it is, but it is. Okay. Is this the real size of this big cat? No. This is a scale of the real one. The scale. So they took the measurements of a real big cat, a mountain lion, a tiger, a puma, and they shrunk it down. Have you guys ever been to Las Vegas?
Yeah. No.
Have you ever seen, if you've gone to Las Vegas or seen pictures of Las Vegas, have you guys seen the Eiffel Tower that is there?
No.
Okay, so if you go to Las Vegas, or the next time you go to Las Vegas, you'll see that there is an Eiffel Tower. Now, is it the same size as the one in Paris? No, it is actually smaller. Also in Las Vegas, you'll see the Statue of Liberty in Las Vegas, at the New York. Is the Statue of Liberty in New York, Las Vegas, the same size as the real one? No, it is smaller. It is a scale of the real one. Have you guys ever played with Hot Wheels?
Yeah.
Okay, so Hot Wheels are little cars, right? If you turn them over, most of them will say the scale at the bottom. They'll give you like, okay, how much smaller is this toy car compared to the big car? My 8th graders in STEM, they build these high schools that you see all around the classroom. They're actually to scale. They measured a real building and then scaled it down to create these models. Obviously, that's not the size of a real football field, but it's a scale model. In some of your art classes, you might do a scale drawing of something. Either create something small or big. Like if I were to draw an ant on my paper, I would probably make the ant a lot bigger than what it is in real life. Have you guys been to Disneyland?
Yeah.
Okay. So, Matterhorn. Matterhorn is a mountain. Does anybody know where the mountain is in real life? Okay, Nelly, put that away. It's in Switzerland. So the mountain at Disneyland is a scale model of the real one in Switzerland. What else is a scale model that you guys have witnessed? Is there anything that you guys deal with that's a scale model? Nope. All right. Well, I have. Could this be a scale model of a mouse?
Yeah. Oh,
It could also be the real one,
No.
because they start off pretty small.
What's a rat? I like you.
How do you know it's a rat?
It's just a rat.
What's the difference between a mouse and a rat?
It's a rat.
Rats are bigger.
It looks like a
nastier.
rat. Rats are
All right, so those are scale models. All right, so, if you ever built a scale model of something, we had to do a lot of scales in 8th grade STEM.
This is a scale model.
So glad you brought these things in for today's lesson. So the wrestler figurines, action figures that he has, those are scale models of the real person. Is that how big that guy is?
No.
Yeah. Wait, who is that? How many toys does he have?
Oh, Rhodes. So he's pretty famous right now.
I don't know.
That's alright. Is this the real size of the real wrestler?
Yeah.
On TV?
Yeah.
Totally. Yeah. So he's a lot bigger. But, oh my god. It's a scale model. I wonder, I can't see that. pretty cool if it did show his
They
skill.
show it on the box.
Oh, well, I knew I should have brought my box in. And I looked at it last night. I'm like, I need to bring that in. Anyways, so let's say this is 6 centimeters, 5 centimeters. And this is Y, and this is X. And the scale factor is 1 to 10. All right, so write it down. It may not make sense to you right away, but remember, I always explain it and hopefully try to make it as clear as possible. Okay, so this is my small triangle, and the art teacher wants you to blow it up, make it bigger, so we can paint it on the wall. And the art teacher says, hey, use a scale factor of 1 to 10, which means make this Brandon triangle 10 times bigger, Alan, and then draw it. So if the model is 6 centimeters, but I want it to be 10 times bigger than 6, what is 10 times bigger than 6? It would be 60. So you see how this line right here is 6. Which line on this one would be 60? Why? Because they match. They go in the same direction. It's the same part of the triangle. Now, if this is 5 centimeters, the red line, and I want to make it 10 times bigger, what would it be? 50. So this side would be 50 because it would be 10 times bigger. All right, so write those two numbers down. Y would be 60 and X would be 50, Brandon, because it's 10 times bigger. Now, the math is extremely easy, so we shouldn't be touching our iPads. All right, huh? Oh, yeah. All right. We okay? So this is level 0.1. Super easy. All you have to do is multiply by 10. All right, now let's draw a rectangular prism. Here's my rectangle. 2 over, 2 up. 2 over, 2 up. 2 over, 2 up. So 2 over, 2 up. 2 over, 2 up. 2 over, 2 up. Okay. Then I connect these two dots on the top. Then I connect this to this dot. And this to this dot. And these two dots straight down. And then this dot to that dot. All right. 7 inches, 3 inches, and 1 inch. 3, 7, 1. 3, 7, 1. Now, here's a question that we learned last week. What's the volume equal to of this rectangular prism? Base times height times width. So what's 7 times 3 times 1?
21 inches. Times 8
Cubed. It's 7 times 3 times 1. So it is 21 inches cubed. All right, so that's separate. Okay, now I'm telling you, so this is like separate. Your scale factor is 1, 2, 3. What does that mean? 1, 2, 3. That means you take this and I want it how many times bigger? 3 times bigger, because it says 1 to 3. So I'm going to make this box and make it 3 times as big. All right, let's draw it. Draw it bigger. I don't think I can do it 3 times as big, but I'm just going to draw it a lot bigger. There's my ginormous box. How much more bigger is it? It's 3 times. So if this side is 7, what do I know? This side is going to be what? What is it? So my scale factor is 1 to 3. 21. So I would take the 7 and multiply it by 3 because my scale factor is 1, 2, 3. So take the 7 and multiply it by 3. What's 7 times 3? 21. Can't really see that, can you? 21. What would y be?
9.
Because I would take the 3 and multiply it by 3 because the scale factor is 3. What is z equal to? 3. Because I would take 1 and multiply it by 3 and I would get 3. Now, let me do this on my calculator. Let's find the volume of this. So it would be 21 times 9 times 3. My volume is now 567. 3 times 9 times 21. 367. What was it before? 21. Big difference, huh? All right. Now let's do one more in our notebook. Can you guys draw a tent, a triangular prism? So I'm going to start off with a triangle. There's really no way to help you draw this that I have learned to do. So I kind of do like a diagonal, not diagonal, but kind of going back, like a shooting star. So, and then this one straight kind of down, kind of connect here. There's my triangular prism, like a tent that I would sleep in if I were to go camping. But I don't camp, so I won't sleep in a tent. Have you guys ever slept in a real tent?
Yeah.
Like on the floor?
Yeah.
Like outside?
Yeah.
And you survived?
Yeah.
Gosh. You're brave. You're brave.
Never doing it again.
Yeah, never done it, won't do it. I don't know. How do you know? With the critters out there and the bugs and the ants. Was it hot or was it cold?
Cold.
Cold?
Hot.
Hot. All right. So 10, 4, and 12 feet. Wow, it fits the whole family. 12 feet. Tent. All right. And I'm going to say that the scale factor is 2 to 1. Ooh. 2 to 1, not 1 to 2. What do you think it means when I switch the numbers, when the big number is first? Am I going to make this tent bigger or am I going to make this tent smaller? Smaller because it's 2 to 1. It's gonna go small, super small. All right, so let's draw a very tiny, tiny, tiny tent. Very tiny tent, so tiny. And we are gonna call this one X, Y, Z. X, Y, Z. Now we're going to make it smaller. How much smaller? 2 times smaller. Half. We're going to halves it. Does anybody know what math is involved when I say half? Divide by what special number? 2. All right, Yaneli, put that away. We're going to divide by 2. All right, so super difficult. What's 10 divided by 2? 5. What's 4 divided by 2? 2. What's 12 divided by 2? 6. So take all of your numbers and divide by 2. We're going to divide by 2 because it's 2 to 1. So this is 5, 2, and 6. 5, 2, and 6. But Miss O'Malley, what if you give us a really hard one and I don't know what to do? Let's see if I can create a hard one. Quick, Miss O'Malley, think of a hard one. Oh, yes. Okay. I'm going to do it like your worksheet. I'm going to call this one A and this one B. Triangle A and triangle B. Scale factor from A to B. A to B is 3 to 1. Actually, no, not 3. 4. 4 to 1. 4 to 1. 4 to 1. And I say that this is 7 and this is X. 7 and that's X. Now, can you do the math real fast, real easy like the other ones? Not really. So what do you do when it's really hard like this? Because you're 7th graders and you might get a hard one like this. Okay, you're going to set up my best friend, a proportion. On the test next week, if you're having any difficulty with any problem, try a proportion. You can solve a lot of different math with a proportion. Okay, so my first proportion will be this. 4 to 1. 4 represents A and 1 represents B. 4 represents A and 1 represents B. Where did I get that information? From the information given. Now, so the top is A and the bottom is B. Where does the 7 go? Will the 7 go on top or the bottom? 7 goes on top with the A. Where does the X go? Bottom. Because I don't know. All right. Now, how do I solve a proportion? We're going to do the butterfly method. So what's in this circle?
4.
What's in this circle? 7.
1.75.
Now, we're going to divide by 4, right? Divide by 4, divide by 4. X equals.
I got 1.75.
1.75. This proportion will help you solve any scale factor problem. Sometimes it's easy to do in your head, like the ones we did in our notes, and sometimes we need a little help from the good old proportion. Divide by 4, divide by 4, and then a little mistake. Scribble. Some sort. Okay. We're not going to do all of them, but we will actually, yeah, we'll start. I'll tell you which ones to skip in a second. Okay. I'm going to do the first one, maybe the first 2 with you. Okay. It's still scale factor. It's pretty easy. I'm going to show you the way that always works. But if you're sitting there going like, Miss Amelia, I think I could do this faster if I do it this other way, then go ahead and do it the other way. The easier way. I'm going to show you the way that it always works. Okay, number 1. Scale factor of A to B is 1 to 2. So, the 1 is your A and the 2 is your B. Okay? The 1 is your A, the 2 is your B. You have 2 to solve. You have an X and a Y. Now, they come from each shape. So, sometimes we go big and sometimes we go small. What does the Y line up to? What is it proportional to? What side on B? The Y is the same side as the 12. They correspond to each other. They're like mother and son. They correspond to each other. One's bigger, one's smaller. Okay, I'm going to set up a proportion to solve this. Okay, A, B, B. Now, do you guys remember how I told you, like, your first fraction is your first sentence? Well, same thing here. This is my first sentence, first fraction. A scale factor of a to b is 1 to 2. So 1 will go on the top and 2 will go on the bottom. So 1 over 2. I got that from the given information. Now, the y. Does that go on the top or the bottom? Where is the y coming from? The a, right? So we're going to put it on the top. What does the y correspond to? It corresponds to 12, and that goes on the bottom because it's from the b, right? All right, go ahead and do the butterfly method while I go drink some water. Or tell me, can you solve for y? Tell me what y is going to equal. Butterfly method, please. And now I need the pencil moving and the brain working. All right, what do we got? 6. Good. Okay, that's the first one. Now the butterfly method. All right, now let's do another butterfly method for x. So this is x. What does x correspond to? What number does x? The 5. Very good. So those two are like mother and daughter. They're the same. They're just one's bigger and one's smaller. All right. So let's set up a proportion. We still use the same first information. 1 to 2 because 1 is A and 2 is B. A on the top, B on the bottom. All right. Where does the x go? On the top with A or on the bottom with B? X. A would go on the bottom. Where does the 5 go? Goes with the A, so it would go on the top. Butterfly method to solve for x. Butterfly method to solve for x. Or you can see it, some of you can see it and know what it is. Sometimes doing the butterfly method just helps you see it. And then you're like, oh, the math is easy, I'm done. Okay, 2 times 5 is 10 times 1x, so x is 10. X is 10. All right. Now let's do number 2. Number 2, we'll do it together. Scale factor Q to P is 1 to 3. Q to P. So here is Q, here is P. They switch the order. So no big deal. Q to P, Q to P. What's the number? Q is my first number. P is my second number. Why? Because it's the same order as they give me. Okay? So Q is 1 and P is 3. So 1 to 3, 1 to 3. All right. What letter do we want to solve for? X or Y first? What do you guys want to do first? Doesn't matter. What do you guys want to do? X or Y? Y. Okay. So here is Y. What does Y correspond to in the big one? 9. All right. Plug in your numbers and your Y. Where would the Y go? Where would the 9 go? All right. Where does the 9 go? On the top or the bottom? Where does the Y go? Top. Using these letters right here will help you not make a little mistake. All right, butterfly method. So we circle this. 1 times 9. 9. 3 times Y. 3Y. Then you solve a simple dimple equation. And what is Y equal to? 3. All right, can you guys start with X? I want X. I want X. So set up your proportion. Does the first part still stay the same? Yep. So this will be 1 and 3. That doesn't change. Now plug in the 4 and the X. Where does the 4 go? Where does the x go? Where does the 4 go? Where does the x go? This is the way that will always work. Some of you can do it without doing this, which is fantastic, unless it's decimal. Then you're going to need it. All right, what is x equal to? Oh, wait. Oh, no, sorry. Q is 4 and P is x. So 4 has to go on top. X has to go on the bottom. We're going to do our circling. 1 times x is 1x. 3 times 4 is 12. Divide by 1, divide by 1. What is x equal to? 12. And that's it. All right. Can you guys do number 4 and 6? 4 and 6 right now. 4 and 6. 4 and 6. Set timer for 2 minutes. But a lot of it's just talking. So you have to listen because I'm going to be talking a lot. I know. Shocking. Because someone like talks. Want to know something interesting? In 8th grade STEM, I don't do a lot of talking. I do more talking. Anyways. Surprise! The school wants to throw the 7th graders a party on Friday. Because they've been working so hard. We want to, create an awesome experience for 7th graders on Friday. We don't know what to get them. It's like pizza, McDonald's, Starbucks. What should we get, right? So, okay. So here's what I'm going to do. I'm in charge of purchasing the food, right? So, and Adam's going to pay for it. Then, is it real or not real? Okay, cool. Okay, so I'm going to ask a bunch of kids, I'm going to survey a bunch of kids to see what we should eat for Friday's party. I'll be right back. I'm going to go ask the 2nd graders what I should buy the 7th graders. Is that something that makes sense? For me to ask the 2nd graders what should be the 7th graders?
Yeah.
No. Am I asking the right people? No. So, when we do surveys, because this is 7th grade math, believe it or not, what I'm talking to you about is 7th grade math. They'll ask you, hey, let's pretend Susie wants to throw a party. Should Susie go ask the 1st graders what the 7th graders should eat? No. What should Susie do? Susie should ask the 7th graders what they want to eat, right? Okay, so the biggest vocabulary words that I'm going to use over and over again, here are my 2 vocabulary words. Population versus sample. Okay, population versus sample. Does anybody know the difference between population and sample? Okay, population is everybody. And sample is a small group of that population. Okay? So if I'm inviting the 7th graders from McFadden, who is my population? My population is every 7th grader. Who can give me an example of a sample of that population? This class. This class would be a sample. Because, okay, I got to order food tomorrow, so we get here by Friday. Do I want to ask every single 7th grader, what do you want to eat? What do you want to eat? What do you want to eat? Don't really want to do that? No. So what do I want to do? I just want to ask one class. If I ask you guys, are you guys a good representation of the 7th graders? Yeah. So I would ask all of you, 30 of you, hey, what do we want? Pizza, hot dogs, hamburgers, Slurpees. I ask you guys, whatever you guys decide, we'll buy for everybody. That's sample and population. Okay, I changed my mind. We don't have enough money for everybody. So I'm gonna just throw a party for my 2nd period class. Okay. What is my population now? This whole class. So I'm gonna throw you guys a party on Friday just for this population. Everybody. Do I want to ask all of you?
Yeah.
No, it's too much time. I only have 20 seconds. The bell's gonna ring. 20 seconds. No, it's not. It's not. It's not. Who would be a sample to ask? Yeah, Adam. And Brandon. And Sergio. Those three guys. That would be a sample of everybody. So if I ask, would you like to eat, Adam, for the class party on Friday? Sergio, what would you like to eat for the class party? And Brandon, what would you like to eat for the class party? Whatever those three guys decide, we're going to get for the whole class. So who's the population? Everybody in the class from second period. Who's my sample? Those three guys. Does that make sense? The difference between everybody and just a little bit people? Okay, now let's pretend I have your grade right here in this piece of paper. I have your grade. I'm finalizing your grade, giving you your last points. And I go, hey, hi, Dina, I'm working on your grade here. Yeah. And so who's your favorite teacher? Now, is that a biased question? So a biased question is it a fair question? Is it fair for me, her math teacher, to stand on, like, over her and, like, I'm just doing your grades, don't mind me. Hey, Dina, I was just wondering, like, who's your math teacher? Is that fair?
Yeah.
No, right? It puts a lot of pressure on her to be like, is she going to take off points if I don't say her name? Gosh, she's standing right in front of me. That's not very fair. So would it be fair for me to do that? No. Now, if Brandon taps on her shoulder, hey, Dina, who's your favorite teacher? Is that biased?
Yeah.
No, because it's Brandon. He has nothing to do with her grade, or he's not going to be my chismoso and tell me later, hey, Dina said this. No, he's not. So that's okay. Imagine if right now we're in an election year, meaning we're going to choose a new president in November. If Biden walks into a group in Santa Ana at IHOP, he goes into IHOP, right? And he asks the people there eating breakfast or Denny's on a Sunday morning in Santa Ana, hey, who are you guys going to vote for? What do you think they're going to say? Like, he's standing right in front of them, right? Biden, right? And Trump is over there at I Heart Pancakes right here. And he walks in. Hey, guys, who are you guys going to vote for? What are people going now? Are they voting? No. But they're just saying. What are they going to say? They're probably going to say that person's name, right? If you play baseball and your baseball coach says, hey, what's your favorite sport? What are they going to say? Baseball. McFadden just got $1 million to spend on sports.
Actually?
No.
Bro.
Who should we ask? Who should we ask to see how we should spend the money? Who gets the most money? What sport gets the most money? Who should we ask? Should I ask all the football players?
No.
Should I ask all the cheer people?
No.
Should I ask all the basketball guys? Why can't I ask them? Wouldn't they pick their own team, their own sport, right? So, should I ask the first grader, hey, how should we spend this $1 million?
Yeah.
No.
Do they play sports?
Yeah.
Not at middle school, right? So, we have to make sure that we ask the right people the question, and we're so good. And it's not biased, not like, should we have homework, Dina, tonight? Yes or no? Too bad. Okay, write this down. Write this down. Population. Everyone. Sample. Just a group of people. Okay? So population is everyone, and a sample is just a group. And we're going to have to finish this tomorrow, because I'm going to have to give you homework.